Here we have a non-right triangle, so we have to be able to split this into right triangles. And there's many different ways to do it, and we want to try to find the easiest way that will help us out. So it looks like here, if we draw the vertical from the top to the base, it looks like we can generate a right triangle here where we have enough information to solve. So we have an angle, a side. We can use then trig to solve for the other sides in the angle. So I'm just going to fill in the angle that I know right now. That's 20 degrees. And we're going to solve for these two sides. Okay, so I'm going to call this M and N. Zoom in a little bit so we can see a little bit better. And I'm going to start by solving for that vertical line, or what we call the altitude, because that's really the key piece in this triangle. So I'm going to use the opposite of 70 at the hypotenuse. Opposite hypotenuse is so we're going to use sine. So n to 10 is opposite to hypotenuse, and that's our sine. That's going to be sine 70. So I need to be able to use my calculator here to get sine of 70 degrees, okay, because I don't know what that is, what that ratio is off the top of my head. So we need to use our calculator to generate that ratio. So sine 70 works out to be 0.9396. So we're going to round that to 40 to 1. And so that means that the vertical side is about 94% the length of that side. Well, we can just times it by 10, and we get the altitude n is equal to 9.4. Okay, so this is a key measurement in this triangle, because now we can relate it to the right triangle. So I'm going to solve for the m first. So m squared, since it's the shorter side of the right triangle, we're going to subtract. It's always the longest side, subtract one of the shorter sides. So 9.4 squared. Now, once we start rounding, we're going to start introducing some errors. So depending on your rounding, you might have a slightly different solution than I do. So I'm going to go 10 squared minus 9.4 squared. Okay, so I'm going to end up with 11.697. So I'm going to just round that to 70 square root. Okay, so I'm going to end up with about 3.42. Okay, so if you're around 3.4, okay, that's pretty good. So now I've solved the left-hand triangle. Now I have to solve the right-hand side triangle, so which has my x, it has my other angle, and I'm going to have to solve for that angle as well, which I don't know. So I only have this side, the vertical side, so far. So that means I don't really have much to work with in this triangle. I have no angles. I don't have this side. I don't have this side. However, this side in here is just the difference between the long side of 15 and the m that I just calculated. So if I do 15 minus that m value, I'm going to call this, what should we call this? We'll call that q maybe. That length of q is going to be 11.58. So now I have two sides of this right triangle. That means I can calculate the hypotenuse using Pythagoras, and I also have now enough sides to make a ratio. So I'm going to calculate x first using Pythagoras. So x squared is equal to 11.58 squared plus, we're going to use 9.40 for the other side, 9.40 squared. Okay, so I end up with x squared is equal to about 222 point something. Okay, I'm going to square root that. And so I end up with x equals 14.91 approximately. Okay, so 14.91 is going to be my length of x. So I'm just going to record that so that I have it. That's one of the pieces I need to solve for. So that's 14.91 is the length. I now need to solve for this angle in here, which I'll call, let's call that beta, because we want the whole angle, which is we'll call b. So angle A, we can then use two sides of that right triangle. So I'm going to use that N and Q. So that's rise over run. So that's tan. So I know that tan angle A is equal to 9.4 is my rise, or my opposite. And then my adjacent, or run, is going to be 11.58. Okay, I'm just going to work out that decimal first, and then I'm going to undo that. Okay, so I have 9.40 divided by 11.58, and that's going to give me a tan ratio of 0.8117. So I'm going to round that to 82. I'm going to undo that ratio and come up with an angle. So I need to use arctan. So arctan of 0.812 gives me angle A, and angle A works out to be 39.06 or 07 I'm getting. Okay, so somewhere around 39 degrees. Now again, my number is going to be inaccurate because I've done some rounding in here somewhere, so this 0.07 is really not all that accurate. Okay, so, but I'm going to just keep with my two decimals anyways. Okay, although it's not quite accurate. Okay, as long as your answer is somewhere around 39 degrees, you've done the right calculation. So the last thing up here is going to be the angle B, which is going to be those two parts. Now I can solve for beta using the blue right triangle and add that to 20 degrees, but we also know that the three angles are supplementary, which means they add up to 180 degrees. So if I do 180 degrees minus the 39.07 minus the 70 degrees, I'm going to be left with angle B. So angle B up top, this angle B, let's get rid of this beta, and we'll just call that whole angle angle B. That angle works out to be 70.93 degrees. Okay, so this is really quite distorted picture because it should look more almost isosceles, and clearly this triangle does not look like that. Okay, so we can't really go by the looks of this triangle either. We have to use the measurements given, and they're not always going to be drawn to scale.